So my name is Jeremy, and I'm an applied research scientist at Mila. And today we're going to focus on machine learning tools. By the way, today is Monday, September 9th, 2019, just for the recording. So let's look at what we're going to talk about. We're going to talk about Python. We're going to talk about machine learning tools in general. What kind of tools do you typically use in a machine learning pipeline? We're then going to focus on some deep learning frameworks. And I'm going to give you some tips about project management when you're working in a team, when you're working on your own projects that involve both machine learning and deep learning. And then I also want to take some time to talk about hardware. So the difference between a CPU, a GPU, and the kind of hardware that you typically find. And the goal of this talk today is to be kind of complementary to what we've seen so far. So Gaetan did a really good job at introducing machine learning, and now we're really going to look more at the kind of tools that we use when we want to do machine learning. So let's start first with Python. So good thing that we practiced raising our hands and waving our fingers. Let's try to do some more practice. Who here has heard of Python before? And I'm talking about the programming language Python. All right, great. So I saw about I think over 90% of the room. Who here has coded in Python before? Okay, still a good amount of you. And who here would say they're good at Python? Okay, all right, that's good. Anyway, so there's already a lot of knowledge of Python in this room, so this is good. So some of this might be a refresh for some of you, and some of this might be completely new. So Python itself is a programming language. It was developed in 1991, so it's just about as old as I am. It's open source, and it's particularly popular in the machine learning and in the deep learning community. You'll see that there are a lot of libraries that are open source and used all the time that people really love. So I want to talk today about why Python is great. There are many reasons why Python is great, but I put a list together for today. So the first point that we're gonna talk about is the Zen of Python. So let's continue here. Who here has heard of the Zen of Python? You see, many people have heard of Python, but not many have heard of the Zen of Python. So the Zen of Python is kind of a philosophy, if you will. It was one of the first creators of the language who essentially put out this list of what was important in a programming language. So Guido van Rossum, the creator of Python, one of his quotes says that code is read much more often than it is written. And this is very central in the Python programming language. Python was designed to be for users. The point is that humans read code, right? Machines interpret code, but humans read code. So there's these lists of, let's say, idioms in Python, and I want to highlight some of them. The first three I find are awesome. So beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Keep in mind that we're talking about code here, but you could also see how this could apply to your everyday lives. And also one that I find really important is readability counts. In Python, there's this concept of everything should be easy to read, and your code should be read like you read a novel. You should be telling a story with your code. So keep that in mind when you're reading Python. And if you read your code and it doesn't feel like it flows like a story, maybe there's a better way to write your code. Okay, so that was my favorite one, the Zen of Python. But really, another reason why Python is great is the rich ecosystem of libraries. So Python itself is a core language. And it has many other libraries around it, third-party libraries that any user can go and create their own libraries if they want. And as a user, you could then go and download these libraries and start using them right off the bat. So one of the reasons why we're here and talking about Python is that there's a very rich scientific computing library ecosystem out there. One of the more popular ones, which I'm sure most of you are probably familiar with, is NumPy, but there's also SciPy, which allows you to do all sorts of scientific computing. Scikit-learn, which is a really popular library for machine learning and implements all sorts of different machine learning algorithms. And then, of course, we have the deep learning libraries that we're going to look at later today, which are TensorFlow, PyTorch, Keras. We're going to look at the differences between them, and we're going to look at where they stand in the deep learning community in general. We then have lots of really rich tools for data visualization. So if you're dealing with data, it's really important every once in a while to take a step back and actually try to look at your data, try to make sense of it yourself. If you can't make sense of your own data, it'll probably be hard for a computer to make sense of the data. So a general good rule of thumb is whenever you're starting a project, try making the data speak to you as a human. We then have data analysis tools. So pandas is a very popular one. There are some other ones as well, but I would really recommend using pandas. It's really useful when you're dealing with all kinds of structured data and even unstructured data, but usually tabular data, so Excel files. A really easy way to import Excel files is using pandas, and then you can manipulate them and transfer them back to NumPy arrays. And we're going to see an example of that later today. Finally, we have different coding environments. So again, for the more experienced users of Python in the room, you know that there are many different ways that you can run a Python program. Some of you might run it directly in the terminal. Some of you might use IPython. Some of you might be more familiar and comfortable with Jupyter Notebooks. And particularly in this whole week, we're going to be using Google Colab, which hosts Jupyter Notebooks. And again, I'm going to talk a bit more in detail about that later in this talk. Finally, you see that there are many different libraries. It's really important to manage your libraries properly. And so there are different tools that allow you to manage your libraries and your versions of libraries. And again, we're going to look at these different tools and how you can use them later through the talk. So the nice, great thing as well about Python is that it's really easy to get started with interactive notebooks. So let's talk a bit about what interactive notebooks are. So an interactive notebook is a way that you can display your Python code in cells and then have the results displayed in line. So here's an example of what this typically looks like. And again, a very popular interactive notebook that uses Python is the Jupyter Notebook. So you're going to get more and more familiar with Jupyter Notebooks and how they work. But what's really neat about them is that you can have these sequential cells, and you can decide to run your code at different intervals, and directly in line have your results there and be interactive. So you see here some examples from these images where you can get some really rich graphs. You can even have some interaction with these graphs. And what's even neater is that you can share these with colleagues relatively easily. And it's pretty easy afterwards, once you've shared it, to have your colleagues run these and be able to tell your story through data. So what we're going to be using throughout this week and in the tutorials later today is what we call Google Colab. So one quick way of thinking about Google Colab is it's kind of like Google Sheets or Google Docs in the way that you can interact with it many users at a time. But really, it runs Jupyter Notebooks under the hood. So the reason why we're using Google Colab is that it runs directly in your browser, and all the computing happens in the cloud. And there's virtually no setup required on your end. So for those of you who are familiar with Jupyter Notebooks, you can still use the Jupyter Notebooks versions. But if we had to have everyone set up Jupyter Notebook, we would have had to have an entire tutorial dedicated in getting started. Right now, Google Colab is sort of, batteries included. What's really neat as well is they give you access to a free GPU, so you can do your computations on a GPU, and you don't have to use your own computer's resources. So it doesn't make your computer slow while you're running code. And again, we're going to use this for tutorials later on today. And when you run a program in Colab, it's literally this easy. You write whatever you want to do. So the typical program that you start with is just a hello world. So you type print hello world in one of the cells, and you're going to see next to each cell that you can run code in, there's a little play button, and you click the play button, and then it outputs hello world.